Imagine standing on the dusty surface of the moon, gazing back at Earth, a swirling blue marble hanging in the void. Suddenly, the ground beneath your boots trembles. Not from a meteor strike or your own footsteps, but from deep within the lunar core. These are moonquakes, mysterious rumbles that shake our nearest celestial neighbor. But here's the twist that keeps scientists up at night. Could these lunar tremors be subtly linked to the fiery giants on our own planet, Earth's supervolcanoes? In this video, we'll dive into the seismic secrets of the moon, the explosive power of supervolcanoes, and explore whether there's a cosmic connection pulling these worlds together. Buckle up. We're about to quake the foundations of what we know. Let's start with the basics. What exactly is a moonquake? Unlike earthquakes, which rip through Earth's dynamic plate tectonic crust, moonquakes are the moon's version of geological hiccups. They're not as frequent or destructive as their terrestrial cousins, but they're real and surprisingly varied. Scientists classify them into four main types: shallow moonquakes, deep moonquakes, thermal moonquakes, and meteoroid impacts. Shallow moonquakes are the most powerful, clocking in at magnitudes up to 5.5 on the Richter scale, enough to rattle equipment but not shatter the lunar surface. They occur just a few kilometers below the regolith, that fine, powdery soil covering the moon. Deep moonquakes, on the other hand, originate about 700 to 1,200 kilometers down in the moon's mantle. These are weaker, around magnitude 2 to 3, but they happen in swarms, sometimes lasting hours. Thermal moonquakes are caused by the extreme temperature swings on the lunar surface, plunging from a scorching 127 degrees Celsius in sunlight to a bone-chilling minus 173 degrees at night. This expansion and contraction cracks the crust like a frozen lake under the sun. And then there are the impact quakes, triggered by micrometeorites pummeling the moon at cosmic speeds. These tremors aren't just trivia. They reveal a moon that's far from the dead rock we often imagine. Our satellite is alive with subtle geological drama, shrinking by about 50 meters every million years as its interior cools. This contraction thrusts up thrust faults, scar-like ridges, especially around the South Pole, where NASA's Artemis program plans to land. In fact, recent models suggest some shallow moonquakes could strike near these future bases, posing risks to astronauts and habitats. How do we even know about moonquakes? Credit goes to the Apollo astronauts, those bold explorers who didn't just plant flags, they deployed science. Between 1969 and 1972, missions Apollo 11 through 17 left behind 4 seismometers, part of the passive seismic experiment. These hardy instruments, powered by plutonium, recorded data for 8 years until their batteries died in 1977. What they captured was astonishing. Over 12,000 moonquakes, including more than 7,000 deep ones clustered along 28 nests in the lunar interior. Analyzing that data today with modern computing has uncovered patterns. Deep moonquakes, for instance, recur every 27.3 days, the moon's orbital period around Earth. This isn't coincidence. It's a smoking gun pointing to tidal forces. Just as the moon tugs on Earth's oceans to create tides, Earth pulls back on the moon, flexing its solid body like a cosmic stress test. These tidal stresses build up and release, triggering quakes in those deep nests. It's a gravitational dance where our planet's hefty mass, 81 times the moon's, stretches and squeezes its rocky companion. Now pivot to Earth. Our home is a hotbed of violence, and at its heart lurk supervolcanoes. These behemoths aren't your typical cone-shaped peaks like Mount Fuji. They're vast calderas, collapsed craters spanning dozens of kilometers. A supervolcano earns its name by unleashing eruptions rated VII 8 on the Volcanic Explosivity Index, blasting more than 1,000 cubic kilometers of ash and magma into the sky. For context, that's 1,000 times the volume of Mount St. Helens' 1980 blast. Yellowstone in Wyoming is the poster child, a bubbling cauldron atop a mantle plume, a upwelling of superheated rock from Earth's depths. It's erupted 3 times in the last 2.1 million years, the last 640,000 years ago, blanketing half of North America in ash. Then there's Toba in Indonesia, whose 74,000-year-old supereruption may have triggered a volcanic winter, nearly wiping out early humans. Campi Flegrei near Naples, Italy, and Taupo in New Zealand round out the roster. These giants don't erupt often, once every tens of thousands of years. But when they do, they rewrite climates, economies, and ecosystems. Ash clouds circle the globe, cooling temperatures by 3 to 5 degrees Celsius for years, devastating crops and sparking famines. Monitoring them is a high-stakes game. Yellowstone's ground swells and deflates like a breathing giant, with geysers like Old Faithful as telltale signs. Seismometers detect swarms of tiny quakes, and satellite radar tracks deformation. But prediction remains elusive. We get weeks or months of warning at best. The U.S. Geological Survey rates Yellowstone's annual eruption odds at 1 in 730,000. Low, but the stakes are existential. So where do moonquakes and supervolcanoes intersect? At first glance, it's a stretch. One's a barren rock 384,000 kilometers away. The others are fiery backyard. But dig deeper, and gravitational threads emerge. Remember those tidal forces causing deep moonquakes? They're modulated by Earth's mass distribution. Supervolcanoes, when dormant, sit quiet, but their magma chambers, vast underground reservoirs, represent uneven density in Earth's crust. A brewing supereruption shifts mass subtly as magma rises, potentially tweaking the planet's gravitational field by minuscule amounts. Could this ripple to the moon? In theory, yes, though the effect is tiny. Earth's gravity dominates lunar tides, varying by about 10% over the month as the moon orbits. A supervolcanic buildup might alter that by a fraction of a percent, perhaps nudging quake timing in those deep nests. No direct observations link them. Apollo data predates modern supervolcano monitoring, but correlations lurk in the numbers. Studies of Earth's tides show volcanic eruptions cluster slightly during perigee when the moon's closest and pulls hardest. Flip it. If Earth's internal churn amplifies tides, lunar seismicity might sink. More intriguingly, shared history binds them. The moon formed 4.5 billion years ago from debris of a Mars-sized impactor smashing proto-Earth. That cataclysm birthed both worlds' early volcanism. Lunar basalts flooded Maria basins for 1 billion years, while Earth's supervolcanoes trace to the same Hadean hellfire. Today, as the moon shrinks from tidal drag, Earth feels the pull too. Lunar recession at 3.8 centimeters per year slows our rotation, lengthening days. It's a coupled system, where one body's geology echoes in the other. Speculation aside, the tie could be indirect. Studying moonquakes refines models of tidal triggering, which apply to Earth's volcanoes. Research on the moon's aseismic zones, regions slow to quake, mirrors supervolcanic silence before eruption. And with Artemis and China's Chang's missions deploying new seismometers by 2026, we'll get fresh data. Imagine correlating real-time lunar rumbles with Yellowstone swells. Could a moonquake swarm signal an earthly awakening? This cosmic interplay reminds us Earth and Moon aren't isolates. They're gravitational partners in a 4.5 billion-year tango. Moonquakes aren't harbingers of doom, but they whisper of connections we're only beginning to hear. As we eye lunar bases amid shrinking faults, understanding these ties safeguards both worlds. What do you think? Fate or coincidence? Drop your thoughts below. Like if you're Team Tidal Conspiracy, and subscribe for more cosmic deep dives. Until next time, keep looking up. The ground might just shake.